Hello everyone. In this video I'll be going through all of the challenge questions in Edexcel's Pure Year 1 textbook, Review Exercise 1. Okay, question 1, part A. Solve the equation x squared minus 10x plus 9 equals 0. So this is a dead simple quadratic. So we can factorize to get x minus 9, x minus 1 equals 0. So our solutions are x equals 9 and x equals 1. Part B. Hence or otherwise, solve the equation 3 to the power of x minus 2 times 3 to the power of x minus 10 equals minus 1. So if we multiply both sides of this equation by 3 squared, or 9, we can get rid of the minus 2 in the power here. So we get 3 to the power of x times 3 to the power of x minus 10 is equal to minus 9. And expanding the brackets on the left hand side, we get 3 to the power of x squared minus 10 times 3 to the power of x plus 9 equals 0. Now, if we let u equals 3 to the power of x, then we get a quadratic in u squared minus 10u plus 9 equals 0. And you'll notice that this is the exact same equation as we solved in part A. So that means that u equals 9 or u equals 1. And therefore 3 to the power of x equals 9 or 3 to the power of x equals 1. So our two solutions for x are x equals 2 or x equals 0. Okay, for question 2, a rectangle has an area of 6 centimeters squared, a perimeter of 8.2 centimeters. Find the dimensions of the rectangle, giving your answers as surds in their simplest form. So if we draw a diagram of this rectangle, we've got x and y. We know the area, xy, is equal to 6, and we know the perimeter, 2x plus y, is equal to 8 root 2. So x plus y equals 4 root 2. And now we've got two simultaneous equations which we can solve. So if we divide both sides of the first equation by x, we get y equals 6 over x. And we can plug that into our other equation to get x plus 6 over x equals 4 root 2. And multiplying both sides by x and taking the 4 root 2 to the other side, we get x squared minus 4 root 2x plus 6 equals 0. And using the quadratic formula, we get x equals negative b plus or minus the square root of b squared minus 4ac over 2a, which gives us 2 root 2 plus or minus root 2. And so our values of x are either 3 root 2 or root 2. And the corresponding value of y, so y is 6 over x from our equation here. So 6 over 3 root 2, multiplying top and bottom by root 2, we get 6 root 2 over 6, or just root 2. And if x equals root 2, then our y value is 6 over root 2, which is 6 root 2 over 2, or 3 root 2. You can see no matter which value of x we choose, our side lengths will still be root 2 and 3 root 2. So our answer is root 2 centimeters and 3 root 2 centimeters. Okay, question 3 says, show algebraically that the graphs of y equals 3x cubed plus x squared minus x and y equals 2x, x minus 1, x plus 1 have only one point of intersection and find the coordinates of this point. So, to find the coordinates of the point of intersection, we need to set the equations equal to each other. So 3x cubed plus x squared minus x is equal to 2x, x minus 1, x plus 1. And we can expand brackets on the right hand side to get 2x times x squared minus 1 using difference of two squares. And that is 2x cubed minus 2x. And taking those terms onto the left hand side, we get x cubed plus x squared plus x equals 0. And factorizing this, we get x into x squared plus x plus 1 equals 0. So we have one point of intersection here, which is x equals 0. And the quadratic in here, if we look at the discriminant, b squared minus 4ac, we get 1 squared minus 4 times 1 times 1, which is minus 3. And this is less than 0, so there are no real solutions to this equation. So we only have one point of intersection where x equals 0, and if we plug that into either one of the equations, we'll get that y also equals 0. So the point of intersection is the origin, 0, 0. Okay, and finally, question 4, the quartic function f of x equals x squared plus x minus 20 times x squared plus x minus 2 has three roots in common with the function g of x equals f of x minus k, where k is a constant. Find the two possible values of k. Okay, so we can start by factorizing completely f of x. So we get f of x equals x minus 4, x plus 5, and x minus 1, x plus 2. And we can draw this quartic using these factors. So we know it will look something like this, a W shape. And we have the roots 4, minus 5, 1, and minus 2. So minus 5 will be down here, then minus 2, then 1, then 4. And we know that g of x is a translation of the curve f of x by the vector k0. So we're moving it k to the right. So if we're shifting this curve to the right, then we know that minus 5, minus 2, and 1 we move to the positions of 2, 1, and 4. And if we're moving it to the right, so if k is negative, then we'll be having 4 move to 1, 1 move to minus 2, and minus 2 move to minus 5. So we need to find the two possible values of k. So in the red case, when we're shifting it to the right, we're translating by the vector 3, 0, so k equals 3. And in the opposite direction for blue, we're translating by the vector minus 3, 0, so k equals minus 3. So our answer is k equals plus or minus 3. And that is the end of review exercise 1.